Hi everyone, our first lesson in Algebra 2 is Lesson 1.1, Interval, Inequality, and Set Notation. You should already have these types of numbers written in your notes, and we're going to go over some examples of these numbers. So natural numbers are also considered the counting numbers. So we would start with 1, 2, 3, and etc. So those are positive whole numbers. Whole numbers are a number without fractions or decimals and cannot be negative. So when we go from natural to whole, 0 comes into play. So 0, 1, 2, 3, and keep going. Integers, now we're getting a bigger set of numbers. They're a whole number that's positive or negative, but we still can't have fractions or decimals. So something like -2, -1, 0, 1, 2, etc. Finally, when we get to rational numbers, those are the ratio of two integers, and they can always be written as a fraction or a decimal. There's an infinite number of these, but I'm just going to write a few here. 3/2 would be one, -5/6 could be one, 2 could be one, 0.36 or 2.66 with the 6 repeating. I want to make a couple of special notes here. The first special note is 2. 2 looks like a natural number to me, and it actually is. However, it could also be in the rational family because we can write 2 as 2/1 as a fraction. This is a special type of decimal called a terminating decimal, because it goes for a certain number of decimal places and then stops. It doesn't repeat or keep going. That should say terminating. And this is a repeating decimal. And a repeating decimal is just what it sounds like. The number at the end just keeps repeating, or sometimes it'll be a series of numbers that repeats. So terminating and repeating decimals can be written as fractions. Therefore, they are rational. So if you want to keep in mind, the word ratio is in the name, rational, ratio. Finally, we have irrational numbers, and those are the ones that don't really behave well. They go on forever and they never stop. The most famous of those would be pi. Pi goes on forever. You learned that in geometry and probably before. Some square roots do this as well. Square root of 2, if you put that in your calculator, it goes all the way across the screen and keeps going. Negative square root of 5. Any sort of decimal that might continue all the way across your computer screen and it never repeats. Think about this one for a minute. Square root of 25. What's different between that and the other ones that I wrote? Square root of 2 and negative square root of 5. This one is not irrational because you can write this as 5 or as 5/1. So it is actually a natural number. Finally, real numbers are basically anything you can think of, anything that is not an imaginary number. Imaginary numbers is something we'll get into in the third 6 weeks. So any number you can think of. A fraction, a decimal, a repeating fraction, or repeating decimal, non-repeating decimal, any of those. All right, go ahead and pause the video here and draw these boxes, and then we'll talk about them. All right, so let's talk about how all of the number sets relate to each other. All of the number sets that we spoke about on the first page are considered real numbers. However, some of them belong to special subsets. Natural numbers are the smallest subset. It has the smallest number of numbers in them. And so these, again, are things like, 1, 3, and 6. All right. Now, I could also write 1, 3, and 6 in the whole number category. However, that's not its most restrictive location, the smallest box. All right, so 1, 3, and 6 are subsets of whole numbers, but the only number that's added going from natural to whole is 0. When we go to integers, again, 1, 6, and 3 could be written there, 0 could be written there, but the thing that we add that couldn't go the other way into whole numbers or natural numbers is negative numbers. So maybe -2, -7, -15. So you can't go from a bigger box to a smaller one, but you can certainly go from a small to a big. Rational numbers, again, just write yourself some fractions and maybe some terminating decimals like 0.5, a repeating decimal like 4.22 with the 2 repeating. And then finally, notice that in a box by themselves, not nested with the others, are the irrational numbers. Irrational numbers cannot be any of those other 4 categories. They're never rational, integers, whole, or natural numbers, and none of those numbers are irrational. So these do not nest, and they are not subsets of each other. So again, if we have a decimal that does not repeat or terminate. Please go to the slide deck and complete the activity that I have for you on the next slide.